Hello everyone, this is Imran Pardesi sir and today I will be starting the new chapter of standard 9th math 2nd chapter number 6 circle. So my dear students, first of all I will start this chapter with the previous knowledge. Just please look at the board and you have to open the textbook page number 76. There is this one kind of activity is there on that page number. So please just look at the board and please try to understand. See here, chapter number 6 circle, previous knowledge. So see here, we have to open the textbook page number 76. This is a circle, a figure is there over there figure. We have to observe this figure and we have to answer this given activity. So first of all we will learn what is circle. So my dear student, the circle means the set of points in a plane which are equidistant from a fixed point in a plane is called a circle. Again, the set of points in a plane which are equidistant from a fixed point in the plane is called a circle. Okay, and that fixed point is called as the center of the circle. So my dear students, here in this figure, you can see the point P is the center of the circle and there are some points on the circle. Okay, they are equidistant in a plane. Okay, and that fixed point is called as the center of the circle. See, now this activity is given on the textbook page number 76. We have to answer it. Okay, see, chord. First column is of chord. So what is the meaning of chord? If you will see in the circle a segment joining one point of a circle to the another point to the circle. Okay, look at here. Here point B and point C, they are joined to each other. Yes, so this is segment BC is the chord. Yes, segment BC is the chord. So you will write here segment BC is the chord. Only BC is their chord. Can you see CD? Segment CD is the chord. Yes, it is also joining one part of a circle to the another end of the circle, one end of the circle to the another end of a circle. So segment CD was also a chord. Yes, we will write segment CD also a chord. Okay, now see the second box. Segment PA, it starts from PA. What is segment PA? So P is the center and from center a line goes to one end of a circle. So this is called segment PA and segment PA is a radius of a circle. So you will write over here it is radius. So this was fill in the blanks here. This was fill in the blanks. Okay. Now see diameter. A segment which is the longest chord and that is passing through the center. Okay. Can you see CD is the longest chord and that chord is passing through the center. So that is why segment CD is the diameter. Okay. So you will write segment CD is a diameter of the circle. Is it clear? Segment BC is a diameter? No, because segment BC is not passing through the center. Okay. So now we will move the next radius. Here we have mentioned radius. Segment PA is a radius, but only PA is the radius here in this figure. See, if the question is talking about radius, you should see the center of the circle. When the word will come radius, directly you should keep your finger or your eyes in the center of the circle. It means here P. So from P to the one end of a circle, PA, radius PA, okay. Segment PA is a radius, segment PC is a radius, segment PD is a radius. So there are three radius. So we will write over here segment PA, comma, segment PC, comma, and segment PD. So there are how many radius are there in this circle? 3. 1, 2 and 3. Total 3 radius are there. Now see 3 radius in the same circle or 3 radius of the same circle. Now see the center. As we have talked about, the fixed point is called the center of the circle. So here point P. You will write point P is the center of the circle. Is it clear? Point P is the center of the circle. Now central angle, okay, so this is new term for you, central angle. It means angle is forming in the center of the circle. So just please look at the board. I will use here a different color marker. Can you see here? It is a center, fixed point. Point P is the center. Can you see this angle? See this angle? CPA or APC. It is an angle. Yes. So this angle, this is an angle. So this angle is forming where? In the center of the circle. Can you see angle APC or angle CPA? Means center comes in between. Yes. So this is called central angle. Okay, and the central angle is equals to the corresponding arc of the angle. So now here also one more central angle is there. Just tell me which one. Can you see here? See this APD. It is also a central angle. Yes or no? So here also I will use some different color to show the central angle. So here APD is a central angle. Okay. Now, can you see this? This is also this one. This is a straight angle. Yes, acute angle, right angle triangle, obtuse angle, and straight angle. So this is a straight angle. Can you see CD is a straight angle, semicircle. So it is of 180 degree. It is of 180 degree. Circle, major of a circle is 360 degree, right? So here we will write what is our central angle. So there are 2 or 3 central angle, but if you understand 2, you can mention the 2. That is angle CPA and angle APD, okay, and angle CD also, CPD, angle CPD, DPC. It is also straight angle, okay, that is also called central angle. So you will use there angle CPA, comma, angle APD, angle CPD, straight angle. Okay. Now see, it is also given over here angle CPA. Angle CPA. CPA क्या है? It is a central angle. So you will write over here central angle. So what is the meaning of central angle? An angle which is forming at the center of the circle. ऐसा angle जो center पे बनता है. Is it clear? So you can see this. This is the central angle. See, this is joining here. This also central angle at P. Yes. So this is the introduction of the chapter. Now we will start the theorem. Okay. So please pay attention. So dear students, after the introduction of circle, we will see the circles in plane. Okay. So different type of circles in a plane. Just please look at the board and try to understand. See here. The first one. Okay. This is the first one. Okay. This is second one. This is third one. And this is, you can say this is the fourth one. Okay, so see, there are different type of circles. So here, can you see the radius of this circle is 5 centimeters. Okay, I have just written for example. The radius of this circle is also 5 centimeter. It means what? These two circles are congruent circle. Okay, means equal circles, same radius. Their radius will be same. So therefore, these circles will be called as congruent circles. Okay, now see here the second one, concentric circles. Concentric, it means common center of the circles. Concentric, con means common, centric means center, common center of the circles. Okay, so see here there is a common center of these 3 circles. One circle is bigger than small, then smaller. Okay, so there is same center but different radii. Okay. Okay, see, same center and the different radius. So this is the property of this concentric circles who's having common center. Okay, but radius of the circles will be different. Can you see one circle is smaller, little big, and then bigger. Okay, now see here the third one, circles intersecting in a point. Okay, so this is a circle. One circle is interior. Okay, so these circles are touching each other internally. This is internally. And this is 2 circles touching each other externally. Okay, here these 2 circles touching internally. Okay, so can you see the bigger circle center is point P and the smaller circle center is point O, and this is the only one point is a common point, that is point C. Okay, see, different centers, different radius, only one common point, that is point C. So here also can you see the two different radius, okay, two different centers, point P and point O, and there is only one common point, that is point C. This is internally touching each other, these two circles touching each other externally. So here the fourth one is circles intersecting in 2 points. Can you see two circles of any different radius, they are intersecting each other at two different, okay, points. Can you see here A and B? So different centers, different radius, and two common points. So this is a different types of circles in a plane. Okay, so now I hope that you have understood what is congruent circle, concentric circle, circles touching each other internally and externally, and the circles intersecting each other. Okay, so dear students, now we will see the theorem, and which is very much important for your examination. So please practice this theorem. Okay, look at the board. The theorem is a perpendicular drawn from the center of a circle on its chord bisect the chord. Okay, this will be a theorem, and this will be the question only in your question paper. Okay, this statement will come as a question in a question paper. So this is a perpendicular drawn from center to chord. See, AB is the chord and point O is the center of the circle. So from center of the circle we have drawn a perpendicular on the chord AB. So what will be the result? It will bisect the chord. Okay, so this perpendicular, that is OP, perpendicular OP will bisect the chord AB into two equal parts. Bisect means two equal parts. See here, so what is given in the question, you have to draw the figure, you have to write the given, to prove and proof. Okay, for 3 marks. Okay, so look at the board. Given segment AB is the chord of a circle with center O. Okay, AB is the chord and center O, point O is the center of the circle, and segment OP perpendicular on chord AB. So segment OP is perpendicular on chord AB. Okay, so to prove, what is to be proved? We have to prove that this perpendicular segment OP is the perpendicular on chord AB. So this perpendicular will divide bisect the chord. Okay, it will bisect the chord. It means we have to prove that segment AP is congruent to segment BP. Okay, AP is equals to BP. Okay, we have to prove. See, segment AP is congruent to segment BP. Now proof, we have to start from, see, we will draw first this radius of the circle. See, we will join this O and A, O and B. What are they? They are the radius of the same circle. We will join from center to one end. So this is radius. This is also will be the radius of the same circle. See, draw segment OA and segment OB. So it will be radius of the same circle. Now see, in triangle there are two triangles. See, OPA and OPB. Triangle OPA, right angle triangle. Triangle OPB, also right angle triangle, because this is OP is a perpendicular on chord AB, so it is 90 degree. Okay, so now we will see that angle OPA is congruent to angle OPB. Why? Each will be of 90 degree or right angle triangle, and because of segment OP is perpendicular on chord AB. Now you can see segment OP is common here also. In this triangle also OP is here, and in OPB also OP is there. It means OP is a common side of both the triangles. Now see the hypotenuse OA. So this is OA is a hypotenuse. Why? Because opposite side of right angle triangle OA is a hypotenuse. Here OB is a hypotenuse because opposite side of a right angle triangle. So hypotenuse OA congruent to hypotenuse OB. Why? Because both are the radius of the same circle. So these both will be congruent to each other. So that is, again you will say segment OP congruent to segment OP. Now hypotenuse OA congruent to hypotenuse OB because the radius of the same circle. Now everything is, we have proved over here, are congruent. It means these two triangles will be congruent to each other. Therefore triangle OPA congruent to triangle OPB, hypotenuse side theorem. Okay, whenever you will see this symbol of this altitude, we will say it is a hypotenuse side theorem. Okay, in this, by corresponding sides of congruent triangle, we will say segment OP is congruent to segment BP. okay, or PB. See, segment PA or AP is congruent to segment PB, okay. So this is from correspondence sides of congruent triangles, okay. So this is how we have to prove the theorem. I hope you understood. Please must practice this theorem. It is very much important for examination.